Okay, so now we have to understand about the why kubelet is important on all the nodes in the cluster and how does the kubelet use the load balancer to connect with the API server. So this video is continuity of how multi-master cluster works and how the failover happens among the different components. Like we understand about the etcd, we understand about the API, we understand about the scheduler and controller in detail. So the kubelet is the component that is running on all the nodes. Scheduler, controller, API, and etcd are components related to the control plane, but kubelet is a service that is running on all the nodes. And in our very initial videos we discuss in detail that this is the only service. This kubelet and the control and the container d is the only service that is running under system d directly, as a service, directly running as a service on the operating system. So let's start. I have this Kubernetes cluster, and if I just show you systemctl status kubelet, so you can see this kubelet is running directly on the operating system. In the operating system, you can say namespace directly as a service, and another service that is running as a directly service that is containerd. So these two components are only running directly in the namespace of the operating system. Rest of all will run in their individual namespaces under the container. So kubelet is running on all our current master node. And what is the purpose of this kubelet? So we will understand from this diagram. Again, I am opening. Here we can see the kubelet is running. In fact, the kubelet is also running on the controller node. The service that I showed you is on the controller node, but here it's not mentioned. Why it is not showed here? Because on the worker node, kubelet is actually responsible to take input from the API server. Whatever new object is registered in the etcd, that will be, you can say, the kubelet will acknowledge to API that you need this pod, this new resource I will create. So in fact, kubelet, if the service of the kubelet is shut down, your container runtime engine cannot run any container, either that is a static pod or pod that is acknowledged by the API server to run. So in the static pod, we know API is not involved. That is directly taken care by the kubelet. I will show you. So why kubelet is not showed on the controller node? Because the workload related to application will not go on the control node. But kubelet is imperative part for the controller node too, for the controller node, all the controller nodes. So that's why it's not showed here. And if I go to my master node, and for example, let me show you if I stop the kubelet service, what happens? So I stop the service, and let's take a look to status of this service. It's dead, it's stopped. And now if I go to the Kubernetes manifest and I just, for example, shut down my API server on this node, and by using the CRI PS, we can see the API server is not shut down because it's a responsibility of the kubelet service of the to take care of this directory etcd kubernetes manifest, that anything change happen in this directory, either new manifest came or anything is removed, that will be taken care by the kubelet service. So we can see the API server is still up, even on the dashboard it is still up. So now when I will start the kubelet service, the Kubelet service will look into this path, etc Kubernetes manifest, and whatever is running, if is not matching with this directory structure manifest, so here we can see it will stop. So API is now stopped, and here we will see that API is stopped on master node 1. So we understand that Kubelet is actively taking care of this directory. Similarly, if I stop the Kubelet and again I bring back my API server, it will not come back until, because the responsibility is Kubelet. It's not coming back. So we must have to start the Kubelet service. As soon it will start, it will bring back the API server, because it will compare, it will make sure that all the manifest placed in this location should work as a static pod. So now if I just go to my dashboard, the API server is back to work. So this was the concept about the API server. Why? Sorry, this was the concept about the kubelet server. So why kubelet is important? One thing we understand, it is important to make sure that your new request related to static pod should be fulfilled. But when we look into the diagram, we understand that on the worker node, it is taking input from the API server. So how does the kubelet use the load balancer to connect with the API? Load balancer, I'm saying in case we have multi-master, but in case we don't have the multi-master, it will directly communicate with the API server. So what are the config files related to this kubelet? So let's just take a look on the status of this kubelet service, and you can see here the kubeconfig file. There are multiple arguments passed with this binary. There is bootstrap, kubeconfig, config, multiple are there, we can see in detail. But I am here interested to just show you the kubeconfig file. And this kubeconfig file is same like the kubeconfig file we are using to interact with the API server. Here you can see the certificate authority is there, and it is communicating with the load balancer IP. Because we have multi-master, any API server fails, the kubelet should have the failover API server reachable. And these are the two files, private and public key use, and this is the system user. This is the user that is responsible to communicate with the API server, and definitely there is some role-based access control and role-based access binding are created uh, to make sure that this can talk with some rights to API. And if I showed you this diagram, here we can see the arrow is going towards kubelet. But we understand that kubelet is communicating with the API. So why the arrow is on the opposite side? In fact, it's on the both side. First, kubelet will make a connection to the API, and then consecutively or all the time, kubelet will hit to the API and will ask for any change. So any change happens, it will apply directly on the cluster. Okay, so for example, any pod dies and you are running some replica set in the deployment, so it will keep asking to API server that how many pods are there for this deployment. So API server knows is all the time connect with the etcd, so it will acknowledge that the number of pods should be 3, so it will make sure the third pod is ready. So this was the communication with the API server. So if we go to any of our master and worker nodes, we can see this communication is working like this, and all the kubelet controller manager scaler all are working with the same way. They are using their own kubeconfig file. They are making communication to the API, and all the time they are in contact with the API server. And if any of the kubelet lost its connectivity with the API server, then the API server will declare that worker node as dead, as not ready. It will not throw any workload and will relocate or distribute its workload to the other worker nodes. So this is the concept about the kubelet, and we test with the load balancer. With the failure, we shut down the kubelet service and we understand how it's behaving. So if you, I right now if I show you my nodes, there is no, my worker node is down right now because I have not power it on. But if you have your worker node and you stop the service, you will see that worker node will be in not ready state. So all the kubelet right now are in working state on all my master nodes. So that's why it's showing here in the ready state.